Hi, let's deal with two-dimensional geometry and how we do drawings. Now, this is the plan of a house. Now, if the architect who drew up this plan and the builder is going to build this plan and the owner is going to eventually own this house, right, and approve it, doesn't understand and have a common way in which these drawings are put together, then we're going to have a problem, because what the creator and the interpreter does, right, might differ, and the interpretation might be different to everybody involved. So we need to have a standard way that we do drawings, and we call this the Cartesian plane, or the two-dimensional coordinate system, right? They're the same thing, they mean the same thing, right? And it is simply a convention, an agreement that everybody's got about how to do things, how to structure it, where positive is, where negative is, how you define the points right along it. We all understand exactly what we're dealing with, and that's very important. And once we've got that, then we can do drawings that mean something to everybody. It doesn't matter whether you're English or German or Japanese. We all understand the Cartesian plane because it is a convention that we've got together in terms of how we do things. So the purpose of this video is for us to get to understanding that convention in the two-dimensional coordinate system called the Cartesian plane. Right, now we know that the stuff belongs in a plane. Planes are infinite in all directions, up, down, left and right. It's a two-dimensional area in which we can draw it. So let's view it as a piece of paper that has no thickness, right? And we'll put this piece of paper down and we'll say, right, we know that a single line, and let's call this an axis, and the convention says we call this the x-axis. Let's say that this x-axis is along there, and we know that a line, right, is one-dimensional. If we put a second line up, we've got two dimensions. So we've satisfied the first thing. We are two-dimensional, all right, and we have an area in which we can draw. We've put them at right angles to each other, and because they're right angles to each other, we now understand exactly where things are. We put a grid in the background of the Cartesian plane, right, simply so that we can say exactly that is 7, right, on the y-axis, and 6 on the x-axis is that point. Right, so the second important part is we needed to have a way to indicate points on the Cartesian plane, and the way we do that is by using brackets, and then we put the x first, we separate it with a semicolon and y. So we've got x semicolon y, and we've separated x from y, so we know at any time where a point is. Right, so where these two lines come together is a very important point. It's called the origin, and in that place x is 0 and y is 0, so that is the intersection of the x and the y axis. Right. So let's look at how we have a plotting area, an area to plot in. Right? So we've now got y infinitely large and infinitely small. We've got x infinitely small and infinitely large on a Cartesian plane. That we now all understand. We've got the grid to help us select points, and we understand that x and y are written like that. But now let's look at some areas. So where would we have x positive? Where is x positive? Right, and it's very simple. It's this area. X is positive in this shaded area. So we look, x is always positive in that whole area in the two-dimensional Cartesian plane. Right? Where is x negative? Well, it must be on the other side. If x is positive here, then x must be negative there. And if we say it, it's in our face. X is minus 1, 2, 6, etc. Right? So minus x is on this side. And we can shade that in, and we can say in this area x is always minus, right? Where is y positive? All right, we're starting to understand this. Y is positive in this area, so that means y must be positive in this area here. So we'll let it catch up to us, right? And y is positive in that shaded area. Okay, and obviously where is y negative? Now x is positive here, negative there, y is positive there, so y must be negative here, but it's telling us minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Y is in that area, so that is where y is always negative. Now we've only looked at one point of the coordinate system here. We've looked at x and y. So let's advance this, and we say, right, show us the area in which x is always positive and y is always positive. right? So we know x is positive over here and y is positive over there. So the intersection of x and y, very, very important, right? That is the area in which x is positive and y is positive, and that is what we call quadrant 1. X positive, y positive. Okay? Now, show us the next one. Where is x always negative? So x is always negative and y is positive. So it's got to be that area. So let's shade it. All right? So x is always negative. Okay? And y is always positive in that quadrant. Quadrant is 4 quadrant, and that's called the second quadrant of the Cartesian plane. Okay? X is minus and y is positive. Right? Where is x negative, right, and y negative? Well, so x negative, y negative, it's got to be this, what we call quadrant 3, right? It's got to be the area where both are negative. And finally, quadrant 4 is where is x positive and y is negative, and that is in the area shaded like that. Okay, so very, very interesting. We've got the 4 quadrants, quadrant 1, 2, 3, 4, right? So we start top right, then we stay at the top, and then we go down, we go in a circle around it like that. Quadrant 1, quadrant 2, quadrant 3, quadrant 4, and in quadrant 4, x is always positive and y is always negative. Right. Let's move on. How do we plot points? Right. So we understand that we write it, our convention is we bracket x semicolon y close bracket, right? So where's y4? Y4 is along a specific line and 3 is along another line. So y4 is along that line, right? Correction, x minus 4 is along that line and y3 is along that line, right? So there y is 3, and we'll let this just happen again, right? Since I've got it working nicely for me in a loop here, we'll just do that again. We'll say, right, minus 4x is along that line and plus 3y is along this line, and where they intersect we have plotted a point, right? And remember, a point doesn't have any space, right? It's just a point in space. It doesn't have any dimension, so we've plotted a point, minus 4x and 3y, and where they intersect, that's where our point 4, 3 is. Right, where's 0, 1? Now, 0 is a very interesting one. 0 is always along the y-axis. 0x is always along the y-axis, right? And 1, y is there. And the intersection point is where the two lines that I've now drawn intersect. So 0, 1 is in 0x and 1y. And that's where they intersect. Good. Now that we know how to plot points, we can now plot solids. So I've got A as being minus 4x and plus 4y. That's there. B as being minus 2x and plus 4y. C as being 2 minus 3, and D 0, 0. Now that we've got that, we can join these points together, and we've drawn a two-dimensional shape, which happens to be a quadrilateral, right, on our Cartesian plane. But we have to know where those points are in order to do that. So let's do that again. A we've defined as being minus 4x plus 4y. We've got A. B is plus 2x plus 4y. Quadrant 1, both are plus. All right. And C, right, is 2x minus 3y. And D, we've just happened to say that's at the origin, right, or the point 0, 0. Okay. So the origin doesn't belong to quadrant 1, quadrant 2, or quadrant 4, or quadrant 3. But the other 3 points are. And if we join these, right, again, we have got a shape, okay, that we can identify as a quadrilateral, right? Let's draw a triangle, right? So we've got A as minus 3.5, x 3.5. That's A. And we've got B as 1x and 1y. and we've got C in the third quadrant as minus 4x and minus 2.5y. And if we join them, we can draw a lovely triangle. Right, thank you very much. Have a look at the video. Look at it again. Make sure you understand it. It's crucial for us going forward. And remember, think positive. Math is great. The more you understand about it, the more joy you get out of it. It's really, really cool when you can sort out all the problems. Thank you.